In example 7, the equation of motion of a particle is s for position equals 2t cubed minus 5t squared plus 3t plus 4, where s is measured in centimeters and t in seconds. Find the acceleration as a function of time. What is the acceleration after 2 seconds? So we've got two problems here. We're going to find the acceleration. After we find that, then we can find it at 2 seconds. We'll plug in 2 for the t. So let's do that now. What we need to remember is position is your original function, velocity would be the derivative of the original function, and acceleration would be the second derivative of the original function. So we're going to have to find velocity first, which would be 6t squared minus 10t plus 3, and then that makes 0. Then we want to find the acceleration of that. So for the derivative of the velocity would be 12 t to the first minus 10. So we've got an acceleration function. That would be the acceleration. And then they want us to find it at 2 seconds. So we're going to plug in 2. Which would be 14 centimeters per second squared. The next property that we just need to know is that the derivative of e to the x function equals e to the x. So it just equals itself when you take the derivative. So let's use that property in this example where we've got e to the x minus x. They want us to find the first derivative and second derivative. So your first derivative, we just saw the derivative of e to the x is e to the x, so that stays. The derivative of negative 1x to the first will be negative 1. Take 1 away, you get 0, so no x. Then we're going to take the second derivative. Derivative of e to the x is e to the x. Derivative of a constant is 0. So that is my first and my second derivative. Example 9, at what point on the curve y equals e to the x is the tangent line parallel to the line y equals 2x? So again, you need to understand the directions here. They're looking for a point, so an ordered pair, an x and a y, to this curve, where the tangent line is parallel. So tangent line means you need to find your derivative, because the slope of the tangent line is the derivative. Parallel means same slope to this line. So this line, we don't need to do anything except find its slope, which is 2. Y equals mx plus b. So b is 0 and m is 2. So I want to know what is the derivative of this and set it equal to, because same, equal to 2, the slope of that one. So we've got the original function e to the x. The derivative is just e to the x, because that property said that the derivative of the e function is just itself. And then we want to set this equal to 2. And to solve for x, we would take natural log of both sides. Natural log is inverses with e. They cancel each other out, so you get x equals natural log of 2. That's your x coordinate, but it asked for a point, so we need to plug it back in and find the y value. To the original, you're plugging it back in. So the y would be e to the natural log 2, and e and natural log are inverses of each other, so they always cancel, and you get 2. So the point is natural log 2 comma 2. That's what they are looking for.